Okay, the last example, we are going to try to minimize the distance because they ask what point on the curve is closest to the point 0, 2. So we want to minimize the distance between the point 0, 2 and some unknown point on the curve. We'll call it x, y. So first of all, we have to know the distance formula. And we're going to make a different function. We're going to actually minimize this function. If we find the x and y that minimize that function, z, that will be the same x and y that would minimize our distance formula. Why did we choose to do this? Well, if I lose the square root, it makes finding the derivative, the calculus part, much more easy. We don't have to do chain rule. We don't have to deal with that negative 1/2 power after the fact. So let's plug in our 2 points to this function z. One coordinate is x, the other one is 0. And then for the other point, the y coordinate is y, and the other one is 2. Now, we need a secondary function because our primary has two variables, independent variables, an x and a y. So our secondary function is actually the idea that the constraint is the point has to be stuck to this curve. So we have to use this function as our secondary function. The good news is it's already solved for y, so I can just go plug it back in for y into my primary. If I simplify the x minus 0 squared, I get x squared plus 4 minus x squared minus 2 squared. I can now take the derivative of this guy since I have one independent variable and look for a minimum product, or a spot where the derivative changes from negative to positive. Before I take the derivative, though, I'm going to do a little more simplification to make my derivative a little easier. I can go 4 minus 2 is 2, so I can call that 2 minus x squared. I can then expand this, 2 minus x squared times 2 minus x squared. Plus, I can go 4 minus 4x squared plus x to the 4th. If I collect like terms and reorganize, I've got x to the 4th minus 3x squared plus 4. So now I can take the derivative and look for a minimum. I got power rule, so it shouldn't be too much of a problem. I set it equal to 0. I come up with this polynomial equal to 0. I need to factor it. So if I common factor out a 2x, I set each factor equal to 0, and those would be our solutions. Let me do that up here. So 2x equals 0, and 2x squared minus 3 equals 0. So we get x equals 0. There's our critical value. And we add 3, divide by 2, square root. Remember, when we square root, we have the plus and the minus version. So the square root of 3/2. You can change that to a decimal if you like, just so we know where that number is. That is approximately plus or minus 1.22. So now we want to make our test interval. I guess I'll do it up here. I've got negative 1.22, I've got 0, and I've got 1.22. Now I can't throw out any values in this because negatives are okay. We're just talking about a curve, right? So I have to pick a number from each interval. So from over here, I'll pick a negative 2, and I'm plugging it into the derivative to see if the derivative is positive or negative. And actually, I'm going to use that version there. I like the factored version better. So let's see if we get a positive or a negative. When I plug in negative 2, I get a negative. Let me give myself some room. I get a negative 4 times a positive number. So that's going to be a negative. Here I'm going to choose negative 1 to plug in to the derivative, that same spot. I get a negative 2 times, let's see what I get here when I plug in a negative 1. A negative number there. So a negative times a negative is a positive. I plug in 1. I get a positive times a negative. And then when I plug in 2, I get a positive times a positive. That's a times. So that's a positive. So now I'm looking for any spots where my first derivative changes from positive to negative. That would be, from negative to positive. That would be a minimum. That occurs here and occurs there. Those are the x values when x is negative 1.22 and when x is 1.22 that are closest to the graph. They're on the graph that are closest to the point 0,2. Now I need to get the y values of those points. So I plug them back into the function, the secondary equation, which was y equals 4 minus x squared. When I plug them in, I'm going to use the exact number, not the decimal approximation, because I'm going to square it, so that's going to get rid of my square root. So 4 minus 1.5 is 2.5. I'm going to get that for both, because when I square the positive or the negative square root, it's going to become positive anyway. So there's my answer. Let's take a look at the graph. I think I still have it on Desmos. It's gone. We can build it real fast. Y equals 4 minus x squared. That should be in parentheses. Right, wait, do I have the wrong function? Sorry. It was y minus 4 minus x squared. I don't need the parentheses. 4 minus x squared. We also had the point 0.2. In our answer, we found out that the point closest to that was going to be the point of square root 3/2 was the x coordinate, and the y coordinate was 2.5. That looks about right on that graph, right? Let's go to the projector mode. Then, of course, there's the other x coordinate, negative square root of 3/2, 2.5. Those are the 2 points that are on the graph, but closest to the blue point, the 0,2.